Speaker, let me remind you of the events in the coming days. On Friday, Center Fellow Maddie Kennedy will be giving a lecture here at the center on Ramsey meets Ptolemy. She's going to be a talk about theory change, so you're invited to come to this talk. On Tuesday next week, we have a lecture online. It's going to be the last featured former fellow lecture given by Sam Fletcher on quantum biology. You can find the website, the link to the talk online. The talk is on Tuesday at noon. On the 5th and 6th of April, we have the last conference of the semester, organized by Senior Teaching Fellow Karl Hofer, right here on evidence-based medicine reconsidered. You can see the program online and also register on the website. I should also add that on the 4th of April, so 10 days from now, our center friend, Jeff Barrett, who has come often to the center, is coming to Pete again, and we're delighted to have him. David here is organizing the lecture. It's at 3:30 on the 10th floor. If you have never heard Jeff give a talk, I don't know what the topic is. Maybe do you know, David, what the topic is?
Yeah, it's algorithm.
Yeah. Yes.
Just really sure about that.
Yeah. That is more recent work on this kind of question. Jeff's a wonderful speaker, even if you're not an expert in the area. So I would highly recommend to go to his talk if you've got interest in the question. So again, it will be on the 4th of April at 3:30 p.m. on the 10th floor. Today, it's my pleasure to introduce Andrea Roselli, who is a semester center fellow. It's been really wonderful to have you here. Andrea is also a postdoctoral research fellow in philosophy at Namur University. We had actually his colleague here a few days ago for a workshop on emergence, which I think a wonderful event. Thanks for organizing it, Andrea. It was very successful. He has been a postdoc at Sun Yat-sen University in the south of China, in Guangzhou, and he was also a postdoc in the Oxford-based Mereology of Potentiality Research Group. Before that, Andrea has published work as an intersection of philosophy of science and metaphysics, mostly on issues related to essentialism and powers. He has published work in synthèse, in erkenntnis, and also in the European Journal of Philosophy. He also has edited a collection on powers in science, also in the European Journal of Philosophy in 2022. All right. Today, Andrea will be talking about some of the work he's been in part doing here at the center on emergence, with a picture from the terrible movie with things emergent beasts and where to find them, but very, very fitting for the talk. Floor is yours, Andrea.
Thanks a lot, Eduard, for the nice introduction. And so, yeah, let me just say before starting that I've been doing this work here. So I've already presented a version of this talk to my colleagues, which have given me some very useful feedback. And also I've tried to engage with some of the people working here in Pittsburgh, in particular, as you will see, Sandy Hitcher and David Wallace. So I have tried to engage with the philosophical community here, and I've also received some wonderful feedback. So in general, the experience has been really, really great. So let's start from this quote by Kim. Those discussing emergence, even face-to-face, more often than not, talk past each other. And that's a feeling that most get when you're engaging with the topic of emergence. And the question is why? Why is that the case? My take is that there is a confusion between a metaphysical notion of emergence and a scientific notion of emergence. So what I will try to do here today is to show what are these two sort of opposing poles of the way philosophers think about emergence, and try to explicitate the differences and to see if we can discard one or we need both of them, etc. So let me just give you a very brief example of the confusion I'm talking about, thinking about emergence and reduction. reductionism is the theory according to which higher level features can be fully reduced to their lower level components. And emergentism seems to be basically the opposite, in the sense that if you think that something emerges, you're saying that some features arise only at higher levels of organization and cannot be wholly reduced to their constitutive elements. So a first naive take might be, well, what emerges is what cannot be reduced. And so you might say, well, the relationship between emergence and reduction is really simple. One is the opposite of the others. However, we see that in the literature, there are a lot of compatibilists. So for example, Max Kistler has just edited a book in which he says basically that emergence is an ontological relation between realities and reduction is an epistemological relation between statements. And even Bedau, in his very famous papers in 1997, Weak Emergence, he says, and I'm reading, the system macrostates are entirely generated solely from the system microstates and microdynamic. At the same time, there is a clear sense in which the behavior of weak emergent phenomena are autonomous with respect to the underlying processes. So it seems like there is a sense in which the system macrostates are entirely generated and determined by the system microstates. And at the same time, there is a different sense in which weak emergent phenomena are autonomous. And it says that sciences of complexity are discovering simple general macro level patterns and laws involving weak emergent phenomena. There is no evident hope of sidestepping a simulation and deriving these patterns and laws of weak emergent phenomena from the underlying microdynamic alone. And this is somehow similar to what Simon Dedeo was saying last week in our workshop. But the question is this really compatibility? In the sense that it looks like these weak emergentists are non-reductive reductivists, in the sense that emergents are reducible from one perspective, but not reducible from the other. So I think that this shows that there is a dichotomy in the current way philosophers and scientists alike talk about emergence between these two ideal opposing poles. A metaphysical notion of emergence, which says that something emerges if it is metaphysically reducible, and a scientific notion of emergence, which says that something emerges if it is explanatorily irreducible. And basically, the two metaphysical notions are a bit confused and merged together in the weak emergentist picture we have seen in Bedau. So another way to show this dichotomy is to say that the two opposing poles in the way philosophers as scientists talk about emergence are that metaphysicians think of emergence of entities or properties, while scientists think of emergence of explanation or theories. And it's not immediately a distinction between ontological and epistemological emergence, in the sense that scientists, as we will see, might take theories to shape ontologies. So even scientists might say, well, but even my emergence is ontological. So it's more a matter of what comes first, entities and properties for the metaphysician, and theories and explanation for the scientists. I say scientists to say philosophers of science in general. So that's a sort of ideal pole. Now, metaphysical emergence, if you endorse this position, you would say that irreducibility of theory does not entail metaphysical irreducibility. So it's entirely possible that you have a higher level theory that it's not reducible to a lower level theory, and still you don't have emergence, because you can say, well, it's just a matter of, it's just an epistemological matter. We cannot explain the higher level features in an efficient way, but still the higher level does not reduce to the lower level, reduces entirely to the lower level metaphysically, and so we don't have emergence. On the other hand, we have a sort of scientific emergence, and it looks like scientists prioritize the development of theories, and then after that proceed to refine and specify what these theories reference. There are, of course, various methods for this process of ontologization of a theory, but the general point is that for scientists, the order is reversed. Theoretical irreducibility entails metaphysical irreducibility. And our own David Wallace is a good example of this attitude. In his view, ontology is secondary. Now, the moral of the story I take from this is that there are basically two ways of intending emergence. They are not identical, and I want to say that neither is theoretically superior to the other. They're simply different. They're about different things. And this also explains why scientists tend to be more liberal in their use of the term emergence, and why emergent phenomena are identified at virtually every level of scientific inquiry, because the reduction of a higher level theory to a lower level theory is relatively rare, and the very existence of a higher level theory seems to show that we need it to explain the higher level, and so the reduction to the lower level framework is far from trivial. So my claim is that once we recognize the dichotomy I'm here pointing about, many philosophical quarrels can be explained away. So for example, consider Sally Mitchell versus Kim. If you think of Kim's famous arguments against emergence, you might think that Kim's notion of emergence is metaphysical in the sense that if we endorse physicalism, then there must be a reduction of the non-physical to the physical. While Sandy Mitchell, I'm thinking of a paper of hers in 2012, she is adopting a scientific notion of emergence where there cannot be a representation that completely captures biological processes purely in terms of physical entities. So she makes this example about a rock and a monkey. There are biological differences which are not captured by the physical description. Both the monkey and the rock are exhaustively physically composed in the sense that any complex whole is made up of simpler physical parts. Still, none of physical properties are biological, and so the difference is not to be found in what they share, which is physical composition, but in the way a rock and a monkey differ. So at a higher level, the monkey is also a biological structure, obviously, while the rock is not. So my point is that even if they are both calling it emergence, Kim and Mitchell are not talking about the same thing. A monkey and a rock are different in some respects and similar in others. Kim is thinking of the metaphysical similarity of two entities entirely metaphysically determined by a physical domain, while Sandy Mitchell is thinking of explanatory difference between two entities as they are individuated at higher levels of our scientific understanding. And so, as I was saying, this also explains why emergence for the scientist is pervasive. Another example is Wallace versus Barnes. So consider David Wallace ontic structural realism. Mathematical structure comes first, ontology comes second. And abstracta earn their ontological status via their predictive and explanatory work. So the emergence of a higher level depends on such operative considerations more than metaphysical ones. Contrast this with Elizabeth Barnes. I could have chosen many other contemporary metaphysicians, in which it's really clear that the way they characterize emergence is in terms of metaphysical, is in metaphysical terms, in particular in Barnes, is in terms of metaphysical fundamentality. She says, an emergent thing is a robust ontological commitment, something new, distinct from the sum of its parts. And so ostensibly, it is one of the things God, which is Kripke's famous metaphor, would have to create in order to make the world how it is. If the table is simply a complex object made of simpler parts, God can create the parts, arrange them table-wise, and we get the table for free. But if the table is emergent, then God cannot just create the parts and arrange them table-wise. She has to create the table as well. So it looks like what is important for Barnes is to explain what counts as fundamentally real, what God has to create, and what counts as derivative, what we get for free arranging the fundamentals. And not what actually in contemporary science would count as fundamental. So it looks like metaphysicians are more thinking about something which is not directly related to our current best sciences. And I realized that once we cast the division in this way, the metaphysical notion of emergence might not look very appealing, in particular to philosophers of science, because it looks that it's really detached from our best current science. So I will try to put forward a moderate defense of the metaphysical notion, drawing an analogy between metaphysics and pure mathematics. Because in a sense, when we think about it, it seems like both are concerned with the development of abstract structures and formal systems independent of any direct application to the physical world. And I mean, we still think that mathematics is useful, that it's a noble enterprise, but it looks like unlike the natural sciences, which try to describe empirical phenomena, pure mathematics operates within a self-contained framework, and it's governed only by logical consistency more than observational verification. And mathematicians, we might say, just as metaphysicians, explore axiomatic systems, construct theoretical models, and establish intricate relationships between abstract entities with no intrinsic requirement that these constructs correspond to or have any direct use for describing physical reality. So the idea is that metaphysics might well be exactly that. Metaphysics engages in the conceptual analysis of fundamental concepts without direct reliance on empirical sciences. So both disciplines prioritize internal coherence and logical rigor over observational verification, constructing theoretical frameworks that aim for explanatory depth rather than immediate applicability. So in general, metaphysicians, like mathematicians, develop models that can be or be not applied to our best empirical observation and categorization of the world. So maybe if we think of metaphysics in this way, we can start to feel at least an intuitive pull towards the fact that we still need to do some metaphysics. And then maybe we can also go a little bit on offense in the sense that if you remember David's slides from last week, there was a jungle with some dragons, and we were supposed to represent the kind of strange places that metaphysics can lead you. And it's true. It's true. I mean, I definitely agree that we can end up in some very strange places. But when we think about it, even a scientific approach sometimes can lead us away from our naturalistic intuitions. So, for example, consider the Everettian interpretation of quantum mechanics, where instead of having a collapse of the wave function, you have a branching of universes. And well, if you endorse this scientific notion, you should say that these infinite worlds really exist. And so this is kind of a strange place. I mean, some endorse this view, but some other might think that it's not exactly naturalistic in this sense. And besides, maybe, we have time. So besides, I would also like to say that some metaphysical modeling is unavoidable from the start, in a sense. So even if objects were empty placeholders, as anti-structural realists say, even if objects are empty placeholders for real mathematical structure, we would only be able to define mathematical structure by choosing the place of the placeholder. So my point basically is either we do pure mathematics, and therefore we can avoid doing metaphysics. But if we try to start writing physical equations, etc., we need to, in some way, to be able to apply the numbers to the physical reality. And that's where the problem starts, and that's where I think one needs to start doing a little bit of metaphysics, in the sense that we can of course avoid to do complex metaphysical reasonings about the nature of photons and particles, their reduction, their fundamentality. We can avoid that, of course, but some metaphysical modeling has to be performed if them and not other things that be chosen as salient placeholders of the interactions. So even if I say, I don't even want to think about photons and particles, they are real, they are not real, sure, but when you're actually writing the equation, you are choosing a specific placeholder, and why that one and not another, and also the sort of continuity that we need in order to have mathematical structures that can work in our theory. This sort of continuity needs a sort of metaphysical modeling. I need to say that what's happening is this relation holds between the same particles, but what does it mean the same? Why those particles? So it seems like this can be resisted, but my intuition is that some metaphysical modeling is always needed in order to start doing physics and not just mathematics. It seems like the more we blur the theoretical depth of these placeholders, and the more we blur the relations, as we don't even know how to individuate them. So the moral of the story is the following: either we do pure mathematics and traffic volume with numbers, or we do physics, and therefore we need to choose some correspondences between the numbers and the world to be able to even begin measuring, calculating, extrapolating equations, etc. All right, so this was just to basically convince you that we might need some metaphysics. Now let me show you what this would mean when it's more directly related to emergence. So these two opposing poles, how would they work? And in particular, the metaphysical notion of emergence, what exactly is telling us about emergence. So I want to analyze with you this case study that points out the difference between the two notions of emergence, which is the game of life. You can see that on the right. Here you also have the four rules according to which this game of life develops. This is basically a mathematical model that simulates complex behavior using 4 simple rules, which are the one you can see on the right. It's basically an infinite grid of square cells, which can either be black or white. Usually, when they are black, they're said to be alive. When they're white, they're said to be dead, to stress a little bit this life analogy. And the system evolves in discrete steps, with each generation determined entirely by the state of neighboring cells. Now, the point is that this game of life produces an astonishing variety of dynamic patterns. So, for example, gliders, you can see even glider guns, you can see objects that seem to create objects. And I guess the point is that the conclusion that one draws from the existence of these high-level patterns in the game of life is a very good indicator of which notion of emergence one has in mind. Consider this quote by this sentence by David Wallace: a macro object is a pattern, and the existence of a pattern as a real thing depends on the usefulness of theories which admit that pattern in their ontology. A glider is a traveling pattern in the excitations of the cells in the game of life. So, according to the scientific notion of emergence, a glider is an emergent entity because of the fact that it is a real thing depends on the usefulness of theories which admit their pattern in their ontology. So basically, the fact that we need a higher level theory to describe these patterns is a good indication of the fact that we have emergence. Metaphysicians, on the other side, will say, well, but the glider is only apparently following higher level rules. So, for example, if you take this glider gun, it looks like you have an object which is continuously producing gliders. But actually, what's happening is that the system is straightforwardly following the 4 initial rules of the game. It may be epistemically useful for us to refer to the glider as a higher level entity, but from an ontological point of view, there is a novelty. This is the metaphysical notion of emergence in play. So I was thinking, how would the metaphysical emergence would look like in this game of life example? And I think one nice way to cash out this difference is to say that in order to describe this metaphysical notion of emergence, we would need to imagine 2 more rules. A 5th rule saying when the configuration X, Y, Z occurs, decrypt and activate a 6th rule. And then we have a 6th rule which is encrypted. So at this point, there really are some in principle unknowable configurations in the game of life, because every time a certain configuration occurs, a 6th rule kicks in. We don't know what this rules in, and it operates on the cells in ways we could have not predicted at the beginning. Say, for example, you start have colored dots that occupy the cells of Conway's game. So it does something completely non-commensurable with what was happening before. So one might say, well, is that strange? Maybe just made up 2 rules. Okay, yeah, it's not so strange. That's my point. Because in a sense, we can say that it's what actually happened here on Earth. So imagine how that would go in a more naturalistic setting. So without knowing the rules from the beginning, we don't have direct access to the rules of the game. We just observe this game of life without knowing the rules. It wouldn't, of course, take too long to notice some regularities. And so we would probably understand what are the 4 rules after a certain number of generations. And suppose this goes on for 500 million years, which incidentally is the time span between Earth and single-celled life. And then imagine that at a certain point, the black dots start, in some cases, to be colored. Now, colors might be said to be metaphysically emergent in the robust sense that some of the British emergentists, such as Morgan and Alexander, we presented some of their theses last week, had in mind. Because with the appearance of colored dots, there is something else in the world, a new specific form of relatedness. And it really looks like it's a new form of relatedness, a new way in which you can relate things. At this point, we might start noticing regularities connected to colors as well, and even that certain combination of colors change the way in which the dots appear and disappear. Say, for example, to reproduce top-down causation, you can say when there are 5 blue dots, a 6th new blue dot appears, which according to the old black and white regularities shouldn't have. So, and this is supposed to represent top-down causation. And we can play with it a little bit and see that we can get a number of nice things. And so I guess this example, which is, of course, this is just a toy example, but it can help us clarify in an elegant way what the metaphysical notion of emergence consists in. Life emerges from a certain configuration of molecules that are not alive. It has additional rules that apply only to that. So, for example, biological rules, and it follows higher level rules, and it's able to causally influence the same molecules that it depends on. So even if, yes, sure, I made up the fifth and the sixth rule, but in a sense, it looks like it's what happened on Earth, because on Earth we had material molecules for a long time, and then at a certain point, a specific configuration of molecules gave also rise to life. So it looks like there is some special combination that gets you something more. Now, of course, you can dislike emergentism and say, no, I just have my dots. I don't want anything more, etc. But of course, if you instead like emergentism, you need to somehow follow the emergentist slogan, which is the whole is more than the sum of its parts, which was already attributed to Aristotle. So you need to explain, in a sense, what is this more? What does it mean that the whole is more? In which sense it is more? And physicalism is the theory according to which everything that exists is ultimately physical. And so if a whole is something more than the sum of its physical parts, maybe it's not even physical anymore. Maybe we need to discard physicalism. And a solution might be to go dualist and say, well, reality consists of two fundamentally distinct kinds of entities or substances, typically the physical and the non-physical. And as you know, the most well-known form of dualism is mind-body dualism, and mental phenomena are not reducible to physical processes. However, this is somehow strange for emergentists because emergence was born as a third way between reductive physicalism and substance dualism. So basically, the whole point of emergence is to avoid reductive physicalism without being a dualist. So emergentists, typically they are monists. And so if there are emergent properties, they have to be made of the same physical substance as non-emergent properties. Now, of course, here there is a problem because if there really are only physical substances, how can there ever be something emerging in a metaphysical, robust sense made explicit in the previous section? If you just have the physical, how can there is something more? Now, an option, of course, is to endorse only the scientific notion of emergence as I have presented it before. And I guess that's what Sandy Mitchell does. She is talking about the V pattern that emerges in flock of geese. And she says, ontologically, there are just physical boards. There is no new substance. Nevertheless, this type of behavior is emergent. And Chalmers, coming, of course, from a different place, but he agrees that this dilemma is inescapable. He says that either we fall back into reductive views where we have emergence only in the scientific sense, so the scientific sense would be reductive for Chalmers, or we expand or reconceive our physical ontology where we can have emergence in a metaphysical sense, but we lose physicalism. And so either we go dualist or we go property dualist when we say that there is just one substance but two different kind of properties, typically physical properties and non-physical properties, or Russellian monism, where you have just one substance but which is at the same time physical and non-physical. So I think this is not really what metaphysical emergentists would want nowadays. So many of the metaphysicians I've been engaging with, they do not want to expand or reconceive their physical ontology, because we at least if you have a naturalist inclination, you want to try to say something which is as close as possible to something intuitively conceivable in scientific and physical terms. But I don't think this dilemma is inescapable. I don't think that either you go reductive or you endorse this scientific notion of emergence, or you need to expand or reconceive your physical ontology. And if you think of what are ontologies, ontologies are in a sense the list of what exists in the world. And so the dualist has two lists. A metaphysical model will then explain how the entities in the two lists are the list of the physical entities and the list of the non-physical entities. And then she has a metaphysics, which explains the ways in which the two lists behave, the entities behave, interact, what laws, if any, they follow, etc. A property dualist has only one list, which is divided, however, in two. You have one list because you just have one substance with two different kind of properties. A physicalist just has one undivided list. So it's the simplest possible situation. You have one list you have a list of all the physical entities, and that's all there is. So it does not seem hospitable to the sort of robust novelty that a metaphysical notion of emergence would require, because you are looking for something more in a metaphysical sense, but then if you just have one undivided list, what is this something more? Chalmers says, if consciousness, for example, is not necessitated by physical truths, then it must involve something ontologically novel in the world. Use Kripke's metaphor, after fixing all physical truths, God had to do more work to fix all the truths about consciousness. That is, there must be ontologically fundamental features of the world over and above the features characterized by physical theory. We need to expand our catalog of the world basic features. But I think there is an option which has not been considered, and we have seen that in the game of life, in the toy example I made before, which is a monist ontology that, however, changes, a sort of mutable ontology. So the question is, why should the list of entities of the physicalist be immutable? The main point of emergentism was exactly this, that in some special case there is something more. So of course, if you don't like emergentism, you don't want your ontology to change. But if you are an emergentist, you are saying exactly that there is something more, that from an ontological point of view, you have something more. And therefore, it's perfectly fine to say that emergent entities are physical, but they appear on your list only when certain configurations obtain. So every time emergence happens, ontology changes. The emergentist can then be a physicalist while also adopting the more robust metaphysical notion of emergence described here. Now, this can sound appealing to the philosophers with a naturalist inclination, and can also be an elegant solution to the problem raised by David Wallace that no ontology-first approach to the problem of emergence can really make sense of the existence of macroscopic level, because the ontology-first approach is, in order to say that the table is really here, I need to say that there isn't something below, because if there is something below, then it is reducible. But a possible solution to that is to say, well, molecules exist, but also the table exists, and there is just a change in if it is emergent, of course, if you consider it to be emergent. So in this sense, you can solve this sort of problem. You can say that macroscopic objects exist if they are emergent, because you can add them to your list of physical entities that exist. So this metaphysical notion of emergence, it might even be said that it has an advantage over the scientific notion of emergence, because the scientific notion of emergence has either a static list of physical elements which are derivable by physical theory, but then it is not clear exactly what it is to emerge, or more than one static list derivable by the special sciences, say the list of physical elements, the list of biological elements, the list of psychological elements, etc. And this is less parsimonious in a sense, and it's also not clear how that is physicalist. So, of course, now you might be thinking there are two different ways in which an ontology can change, in the sense I'm saying. In the sense that an ontology can get richer, or it can just modify. In other words, either the emergent phenomena are added to the list, or they substitute other elements. In both cases, in a sense, satisfy the emergentist login that the whole is more than the sum of its parts. But just they do that in a different way, because in one case, you literally have something more in a quantitative sense. In the other way, when you substitute elements, you probably have even less elements from a quantitative point of view, in the sense that if you say that a person is emergent, and you want to say that you want to say that you have this entity in your ontology, you can, but it substitutes all the elements from which it emerges. Well, basically you have less elements, but you have something more qualitatively, in the sense that a person is something more in the emergence sense that just the sum of the molecules that compose it. So for the physicalist, the two options would unfold as follows. Now, of course, there is no need to be physicalist. You can also be a non-physicalist, and it's pretty straightforward. You have a monist ontology in which you have physical and non-physical elements, so it's really easy. But there is also a way to be physicalist and be emergentist. So how would these two options work? Well, if the emergentist physicalist consider emergence as additional elements in their physicalist ontology, she needs to insist that the newly added higher level elements can coexist with the already existing elements, and everything is physical. In a sort of, you have a sort of multiplication of the physical entities. So when you have the molecules composing a person, for example, you can say, I have the molecules and I also have the person. I have one entity more. This might be taken to correspond, in the toy example made above, to the emergence of colors. The physicalists would need to say that we have configuration of life cells, and at the same time, we also have colors, all at the same physical level. You can say it's all physical. But it can also be taken to correspond to a different sixth rule. So instead of thinking about colors, you can think of a rule that says, because thinking of colors hints at an incommensurable higher level. You can also think of something different. So for example, you can think of a sixth rule which prescribes the emergence of additional configurations at different places of the map. So you have, it's all at the same level, you just have different entities somewhere else. This is probably more easily accommodated in a purely physicalist ontology, but it still comprises a multiplication of physical entities. Then what about the other horn of the dilemma? She can consider emergence as substituted elements in her physicalist ontology. And in this way, she avoids the multiplication of physical entities. And she just needs to say that instead of physical elements, we have another. And this would correspond in a game of life, for example, to a sixth rule that replaces configuration. So when a certain configuration obtains, a sixth rule comes in and it changes the configuration. And it's supposed to basically translate what happens when a certain configuration of molecules gives you a person instead of giving you a rod. Now, in conclusion, my main goal was basically to show the dichotomy and its effects on the current debate, and to analyze and defend the metaphysical notion of emergence, because I think there might be more skepticism about this than about the scientific notion of emergence. And one point for future research is, can this way of shaping the notion help us overcome some of the difficulties? Thank you.
We'll take a break, and then we'll have plenty of time for questions.